So far, right? All the forces are acting on the same point. You just need to start out knowing some terminology. Concurrent forces. You need to know the term concurrent forces. Concurrent forces are forces that act on the same point. Forces that act on the same point. So if all the forces are acting on the same point, can I have rotational motion or just translational motion? Just translational. So Peter, grab this. He and I are both pulling, and the only thing that can happen is translational. It's only when Peter pulls, no, he pulls on this side, like loose, and I pull on this side that we actually have rotational. Because now they're not concurrent forces, right? Because his force is directed on this side of the container, and mine is directed on that side. But when they're both on the same point, you can only have translational motion. So up till now, we've only looked at translational motion. We found resultants that had values, and then we did statics problems where there was no translational motion. Okay, let's go to the top one. You've heard the term concentrated load before, right? What does a concentrated load mean? All the load is concentrated at that one point. So the load is, and there's another term for that. I know you've seen it before. Point load. You heard the term point load? So a concentrated load is the same as a point load. Equals point load. There are synonyms. So up here, let's take loads. And what's another name for loads? Forces. They're divided into two. Point loads, which are also called concentrated loads. Or they're distributed loads. So point loads or concentrated loads are loads applied only at one point. Distributed loads are loads not applied at one point, or they're spread out. Those of you who took materials, what did you learn about? It was a way that you distributed loads at times in materials. What was that called? Do you remember? I'll give you a hint. Loads could either be distributed, that's not right, distributed over area, and there's also distributed over length. And in materials, you worked with that one. What was that called? Force spread out of the area. Force divided the area. Pressure or stress? Pressure or stress? Even though pressure is force divided by area and stress is force divided by area, they're not synonyms. When do you use the word pressure and when do you use the word stress? Give me an example of when you use pressure. Gas. How about liquid? Water pressure in a pipe? Air pressure in a tire? So when it's a liquid or a gas, you use the term pressure. Water pressure, air pressure.
So it's a fluid.
When do you use, fluid. When do you use stress? Solid. Oh boy. I have to finish this. So we have point loads versus distributed loads. So when I take my weight and I wear snowshoes, what am I doing? I'm distributing my load over an area, okay? So take a look at this picture on the bottom, and I think I drew the horizontal line on top. So this is a distributed load. Is it distributed over area? It looks only 2D to me, right? This is really a three-dimensional concrete floor, but in statics, many times we take a 3D problem and we make it 2D. So this is distributed over length. And you see the abbreviation I have here? It's little w is equal to capital F over L. So where stress is force over area, this is force over L, because it's force over length. Okay, so let's go back. We either have concentrated loads or point loads, they're synonyms, or we have distributed loads. We learned that concurrent forces are what? Forces that act at the same point. What do you think about collinear? What do you think that term means? Forces that act along the same line. Act along same line. What do you think coplanar means? Acting on the same plane. Acting in same plane, sorry. Or on same plane. F1, F2, F3, and F4, aren't they on the same plane? They're on the vertical plane. And then parallel forces. So on the worksheet, on the bottom, I have A is point load, B is concentrated load, C is concurrent, D collinear, E coplanar, F parallel, and G distributed loads. So what I want you to do is, looking at each one of these 6 scenarios, I want you to circle. So let's look at number 1. That's a concentrated load, right? So circle B. Is it also a point load? Yes, because the concentrated and points are the same. Circle A. Are they concurrent forces? Are they acting on the same point? No, so don't circle it. Are they collinear? Do they act along the same line? They do not act along the same line. Acting along the same line, this is the example. They're acting along the same line, not parallel. There's a difference between parallel and the same line. Okay. They might have the same direction, but they're not on the same line. Coplanar, are they acting on the same plane? Yes, they're both on the vertical plane. Are they parallel forces? Yes. Are they distributed? No. Okay, so I want you to go through each one of these. And this is somewhat confusing with this new terminology. So come see me and I can help you with it. Okay?